Dear students, welcome to our class on practicals on solar radiation. Very interesting class. Before we go into our class, two small suggestions are request to you. One, our YouTube channel is Agrometrology, Farmers and Rural Development. Please download the experiment on practicals on solar radiation because there is an internet problem. So if you say well in advance, you can study whenever you find time. You can before you go to the practical class, you'll have wonderful opportunity to understand the things. And the second thing is, please always note that when you go to measure solar radiation in any crop, even whether it is a cereal crop, pulse crop, or oilseed crop, or you can say commercial crop like sugarcane or cotton, or in a plantation crop, you need to have some basic understanding of the what is solar radiation, what are its uh, characteristics, the physiological response of crop plants to different bands of incident radiation and the factors affecting the distribution of solar radiation within the plant canopies or crop canopies. So these are all the things that I had given in the solar radiation theory. Try to use the basics in the at the PG level and PG level. I go on adding. So before you go into this class, just to try to understand from our YouTube channel, Agrometrology, Farmers and Rural Development, the solar radiation theory, so that you can do this practice. Very interesting, uh, excellent practice you can do it. Now, so a quote before we go into the class to inspire you. What is the quote? What God gives is never exhausted. What God gives is never exhausted. What man gives never lasts. What man gives never lasts. So this is how. So let's go into our class straight. So what is solar radiation? I need that to say of the three forms of transmission of energy: conduction, convection, radiation. Radiation is the form of energy coming from the sun, falling on the earth without the presence of the medium. Okay. Now, when energy is transmitted from sun to the earth through the atmosphere, okay, there is no exact medium, in which. So such energy, when it comes from the sun, we call it as the solar radiation. Incoming solar radiation is also known as insolation. Okay, so this is what is solar radiation. There are three bands: ultraviolet band, light band, infrared band. Ultraviolet band up to zero point 0.4 to zero point 0.7 light band, 0.7 to 1. Okay, near infrared 0.7 to 4 microns are short wave radiation. Usually from 4 to 120, we call it as the long wave radiation for micrometeorological and micrometeorological purposes. This is a small background, so let's go to the instrument used for measurement of radiation for the study of microclimate. As I said, I did my PG, I did my PhD on micro and macro weather elements. For PG, it is wheat. For PhD, it is soybean crop. Okay, right. So the instrument that I used, okay, are only given here. For any questions, you're always welcome. It's very interesting, very interesting class. It gives you a lot of knowledge. Now, so just what are the things? Line quantum sensor, net radiometer, spectroradiometer, pyrometer. These are the things that the basic instruments. There are for lux meters, so light meters, what not, innumerable solar radiation measurement instruments. These are the basic things. Now, so there are certain principles involved in this one that the basic class you need not know, but just to try to understand the okay. In general, the radiation may be detected in four ways. Usually, in general, okay, what are those? Rise of the temperature of the receiving surface, response of photoelectric cells, photochemical methods, so photographic emulsions. These are all the basic things. However, in the meteorological observatory, not in micrometeorological observatory, there are certain instruments exclusive for measuring the global radiation. So what are those? Direct solar radiation, okay, long wave radiation. All these things are measured in the meteorological observatories commonly. Okay, so pyrometer or solarimeter, direct and diffuse solar radiation. Fire heliometer, direct solar radiation. Fire radiometer, solar and long wave radiation. Fire geometer, long wave radiation. Of course, net radiometer, radiation flux. This is how a solarimeter looks. This is a hard work by me. Okay, it took enormous amount of time just to give you a display of the solarimeter. Similarly, a net radiometer. This also took enormous amount of time and energy for me to draw. Of course, for the basics class, just to how a net radiometer looks like, nothing more than that. Now, so measurement of short wave radiation. As I said, the solar radiation, okay, the distribution of energy into different bands of the into different bands is known as solar spectrum. So what is solar spectrum? There are three bands: ultraviolet, light, and infrared. Near infrared, far infrared. And then several times like good. So what is very very important is go back to the basics. What I taught in the theory. Okay, so physiological responses of different bands of incident radiation that you should understand. Then, what are the factors affecting the distribution of solar radiation within the plant countries? Then you come to this exercise. You will be very, very interested to know. So, what is it? By using the layer technique. What is the layer technique? That I will tell you after 1 second. The relative radiation intensity of the crop cannabis can be measured. What is the layer technique? Simple. A crop is like this. It is divided into different layers. Layer 1, 2, 3, 4, 5, 6. It is divided differently. This is radiation. What is the Beer's law? Tell me. The relative radiation intensity. The relative radiation intensity decreases exponentially with increasing leaf area from the top to bottom. The relative radiation intensity decreases exponentially with increasing leaf area. So leaf layer technique means layer technique. Different layers are taken. Now simplest, easiest, but wonderful interpretation. What is this formula? Tell me. So the formula is RSZ is equal to RST exponential of minus KF. Okay. What is RSZ? You wanted to know. Solar energy is falling on the crop at certain level in the crop. You wanted to know Z, RSZ. Okay. You wanted to know how you know it. RST exponential of minus KF. What is minus KF? That I will tell. RSZ, short wave radiation available at level Z. Short wave radiation, RSI, short wave radiation available at 1 meter above the crop. E is the Neperian base exponential, okay? K is extension coefficient, F is good. Leaf area index, what is K? K can be uh, obtained from log of RSG, ground level. RSG at the ground level. RST, function of a leaf area. That means radiant energy falls. For example, this is the crop. Radiant energy 1 meter above RST. RSZ, you wanted to know? RSZ, just 10 centimeters above. So, for over 30 years, I taught my students, and my MSc and PhD students have worked on this technique. This is one of the simplest and wonderful technique to know radiation interception. This law, once again, I would like to press upon you. The relative radiation intensity decreases exponentially with increasing leaf area. That's why layer technique is a simple equation. Of course, so my colleagues in the crop physiology also may have taught to you the same experiment from micrometeorological point. I would like to press upon you that in the crop cannabis, if you measure, okay, RSZ, RSZ here at certain level, maybe 50 centimeters on the top of the canopy, okay, RST, RSZ, RSG. These things only. Leaf area, as far as each leaf is concerned, if you take, you get the RSZ values of radiation interceptor. More the radiation interceptor, more the biomass producer. That's how we interpret for the PG and PhD experiments. Now, so what is the very important? We should note some important thing. In the same way, it is easy to measure the long wave radiation also in a crop canopy. It may be noted that the above procedure is a modification. This is a modification of the Beer's law. Okay. Once again, and once again. The relative radiation intensity decreases exponentially with increasing leaf area. Okay, so leaf area technique. Okay, layer technique is followed. RST, 1 meter above the crop. RSZ, you wanted to know at 50 centimeters from the top of the crop, how much is intercepted. Okay, so you should take 10 centimeters from the ground. RSG, from that leaf area after leaf area. Okay, you will be calculating layer wise 10 centimeters, 15 centimeters, or anything you take depending upon the height of the crop. Now, so what is the exercise? What you can do as a UG student of first year? Very, very basic exercise to measure the different components of solar. You wanted to measure the different components of solar radiation. How? So, pyrano albedometer, you take pyrano albedometer. Again, I am telling you in the live demonstrations, I am giving you pyrano albedometers up to that point. Please understand there is a pyrano albedometer. Now, so available information that forget I have already told several times. Principle of the pyranoid barometer: when the radiation is incident on the sensitive element of the instrument, it produces electric current, which is measured in millivolts with the help of the millivoltmeter. Simple. Now, simple procedure: you take the pyranoalbedometer. Pyranoalbedometer handheld. It can be handheld. Of course, your body radius should not, so that it should not influence, so that you keep the pyranoalbedometer just slightly away from your body always when you're taking the crop feed. So correct the pyranoalbedometer properly to the millivoltmeter. There is a millivoltmeter. So millivolts, in the millivolts only we get the readings. Now, so keep the instrument ready for taking the observation by setting on. Simple on. So level the instrument if needed by using the spirit level. Incident radiation, diffuse radiation, reflected part of the radiation shall be recorded simultaneously. Now, first I am telling you, incident radiation, that is all, both long wave, short wave, this is incident. Okay, what is diffuse? Now, some radiant energy is falling on me. Now, if I keep it here, okay, there is some shadow. If you measure here, this is the diffuse radiation. Direct, diffuse. The direct is falling, diffuse is when it is cut off. So diffuse light path, you get it simple. So incident radiation, diffuse, reflected radiation. When radiation is falling on this one, something is reflected. So direct, diffused, reflected. But it is not transmitted, please. Direct is here. Direct is here. Diffused radiation, okay, is here. So direct to diffused, reflected from here. So pyranoalbedometer is the simplest instrument. Very easy. Slightly expensive, but sturdy, very, very sturdy. Okay, you can use it in the even toughest condition, cool condition, hot condition. It gives wonderful equations, a wonderful measurements. Now, so normally a bare soil, I give you the table. You take the readings on a bare soil, a dry turf, a wet turf, or a crop can be maybe values. So for every 15 minutes you take. How? I give you a table. Okay, this is how calculate the albedo. What is albedo? The ratio between the reflected to the incident radiation is known as albedo. Right? So direct radiation is equal to incoming radiation minus the diffuse radiation. Direct. Here, direct radiation is falling. Diffuse radiation means, just when you cut off. Direct radiation when you cut off. Diffuse radiation. So incoming radiation minus diffuse is equal to direct radiation. If you stand away from the tree, if you stand away from the tree, direct radiation falls on you. If you go near the tree, diffuse radiation falls on me. When you go away from the tree, take a measure. Come to in the shade of a tree, take a reading. The difference between is direct radiation. Simple. Same like a crop. Albedo, as I told several times, reflected radiation by total incoming into 100, because albedo is measured in percentage. Units of measurement of albedo is a percentage. I told in the theory. Simple. Just you take. This is a wonderful experiment which I conducted for 30 long years with students, just joined students. Very, very simple, very interesting. Take a bare soil, take a dry turf, take a wet turf. Okay, mean values, mean values, mean values. Incoming. Keep the pyranoid limit incoming. Diffuse, just cut off. Diffuse. Reflected. Okay, that means you invert the pyranoid barometer. Reflected, you get direct to reflected to diffuse. Simple. Right. This is how you can put it. Now, exercise number 2, to measure radiation interception. As I told, the relative radiation intensity decreases exponentially with increasing leaf area. Beer's law, modified Beer's law, well, not exactly Beer's law, slightly modified Beer's law. If you take a glass full of water, I'm not saying the same physical principle, glass full of water, put 1 rupee coin or 5 rupee coin, you can see it there. So, there, from the surface of the water to coin, you observe there are certain things going on. All, if not the same, if not the same, and if not the same, similar thing happen as far as direct radiation interception layer wise is concerned. That principle you remember. Here also you take the pyranometer and the pyranometer and millivoltmeter. You wanted to know the interception. Good. How you know it? Simple. This is also my hard work. Well thought of. How if a rows between rows, rows of the plant is white, how you put it? Above the crop canopy, middle of the crop canopy, ground level. Okay, so this much, enormous amount of time I took. This is my own brain child, hard work drawn. Okay, you can measure like this procedure. Okay, what is the procedure? Correct the parameter proper to millimeter, like first exercise. Keep the instrument horizontally. You wanted you use the spirit level, observe the readings and record. What are the readings? This is the crop, for example. This is the crop. Radiant energy falling, incoming. Okay, direct otherwise. Okay, right. So, what is intercepted at the Z level? RSZ. Okay, simple. RSG, 10 centimeters away from the ground. Same thing. So, you record it. RSZ, RSG. Calculate the leaf area index calculation. Is very very simple. It is how much leaf area is there for unit ground area. That's easy also. Now, same things as first one, record it in the record sheet. Now, so to sum it up, exercises are very simple. These exercises may be taught to by my own colleagues in the crop physiology or plant physiology in agricultural sciences. They must have explained to you from the micrometeorology point of view. I'm explaining here as an agrometeorology course student. You should know what is direct, what is diffuse. Direct means direct means So what is coming, incoming. Okay, it combines both diffuse radiation, incoming radiation. Direct and diffuse incoming. Direct plus diffuse incoming. Okay, you wanted to cut it off. So that diffuse away from the tree. For example, you get the full incoming. Go into the tree, you get only diffuser. So you from the incoming minus diffuse is direct. So that much what is there at the crop, above the crop 1 meter, 50 centimeters into the crop, 10 centimeters above. This is how I had given also the time quantum sensors, positions also. This is my hard work, as I told several times. 30 long years, several batches. My own students have worked. They proved it. Wonderful experiment to know basics. I am not taking advances. This is the basics. Now, so some conversion formula as I have already given. Now, units of solar radiation. Before I say thanks to you, so I would like to impress upon you once again with the quote of the day. What God gives is never exhausted. What God gives is never exhausted. But what man gives is just never, never, and never last. It will never be with you. So trust in God. Never, never it is exhausted. What all God gives is never exhausted. So may God bless you. All the very best. Thanking you very much for your patience.